and the trumpets they go.
Hello class. Stoichiometry, you ask? Stoichiometry is a branch of chemistry that deals with amounts and percents of compounds and substances.
Hello. We will be analyzing and illustrating the reaction of lead-2 nitrate with potassium iodide to form lead-2 iodide precipitate in aqueous potassium nitrate. Now, the coefficients in a balanced chemical equation show the relative numbers of moles of the substance in the reaction. As a result, you can use the coefficients in conversion factors called mole ratios. Mole ratios bridge the gap and can convert from moles of one substance. If one has grams, then all you need to do to go from grams to moles is to divide by the molar mass. And to go from moles to grams, you have to multiply by the molar mass of the substance.
The scientists started out with 75 milliliters of distilled water in a 250 milliliter beaker. Using a piece of weighing paper, the chemists weighed approximately 0.9 grams of potassium iodide on a balance. The chemists then added potassium iodide into the distilled water and stirred. They weighed approximately 0.8 grams of lead nitrate on a balance with weighing paper and added the lead nitrate to the distilled water. When this happened, the previously clear solution turned bright, murky, fluorescent yellow, and as the students had previously learned, color change and formation of precipitate can allude to chemical reactions.
In order to obtain the precipitate, the scientists had to filter the solution with filter paper for only twice as shown and had to wait for the moisture to dry in order to measure the precipitate form. It is now the next day, and 0.86 grams of lead iodide had formed. Since the weight of the filter paper was 0.01 grams, and the weight of the filter paper and the precipitate was 0.87 grams, to find the weight of the lead iodide, what you would do was subtract 0.87 grams from 0.810 grams, which would equal 0.86 grams, which is the weight of the lead iodide produced. Let's see if our fellow smart classmates can do stoichiometry.
So as you can see, well, this is going to be on your exercise, so you guys need to know stoichiometry, especially you, Anya.
Yeah, about stoichiometry.
Is that stoichiometry?
Yeah.
I can help you with that.
As per the instructions, we found that a theoretical amount of lead iodide produced by both the lead nitrate and potassium iodide. In order to do so, a balanced equation is needed. As you can see, for every 1 mole of lead iodide, there is 2 of potassium iodide and 1 of lead nitrate. We set up an equation to convert grams of moles, then moles of one substance to moles of another, and finally moles to grams of our desired substance. And that process is called stoichiometry. Since the PbNO3 produced the least lead iodide, it is the limiting reagent.
In order to find out the amount of other reagent produced, we subtract the amount that reagent produced by the amount the limiting reagent produced and solve for the excess reagent using the balanced formula. In this case, it was 0.108 grams of potassium iodide.
Oh my god, are you master chemist? Do you know the fonts?
Oh, yes, I am. Thank you, young man. Have you ever know what percent yield is? Percent yield is the ratio relating the actual yield of a reaction to the theoretical yield of a reaction. Calculating percent yield is similar to calculating the batting average. Percent yield equals actual yield over theoretical yield multiplied by 100.
Since percent yield is actual yield over theoretical yield, you would take the amount of lead iodide produced by the actual results and divide them by the theoretical yield of the limiting reagent, lead nitrate. Afterwards, multiplying the decimal by 100 to find the percentage, with the percentage being 78.2 grams of lead iodide. There are several reasons why the actual yield is usually less than the theoretical yield in chemical equations. Many reactants do not completely use up the limiting reagent. Instead, some of the products turn back into reactants so that the final result is a mixture of reactants and product. In many cases, the main product must go through additional steps to purify or separate it from other chemicals. For example, banana flavoring must be distilled or isolated based on its boiling point. Solid compounds such as sugar may be recrystallized. Some of the product may be lost in the process. There are also other reactions called side reactions that can take up reactants without making desired products. Percentage yield can help one figure out the actual yield in any situation, and even useful in your daily life right now, from factories to Coke bottles.